Hey everyone, welcome back to another episode of Blueprint. My name is Nikzad and this is the third and the final session of TouchDesigner Beginner Workshop. Today I want to shed more light on different communication methods that help us to interact with our network or patch through bidirectional communication protocols. Protocols such as OSC, MIDI, UDP, and TCP for sharing data or signal and sometimes DAT tables. Also, I'm going to explain a couple of useful ways to have a more stable communication when we want to share textures between TouchDesigner and other software, or when we're dealing with sharing signals or again texture between a couple of TouchDesigner instances. And finally, at the end of the second part, I'm going to explain how you can use your smartphone or your tablet as a UI interface to control your network inside of TouchDesigner. Okay, let's start with data communication and network protocols. In order to exchange or transfer information between hardware or software, there must be a pre-existing agreement that defines how the information will be structured and how each side will send and receive the information or data. So a network protocol includes all the sets of well-defined rules for communication or transmitting data between network devices. In other words, network protocols manage all the ways that different devices can recognize or identify each other and make connections with each other in the same network. Also, network protocols formatting a set of rules for packet switching. Packet switching specifies how data is packed inside of send and receive information. All the modern protocols for computer networking usually use packet switching techniques to send and receive messages in the form of packets. These packets are messages that divided into different pieces, and these pieces are collected and reassembled at their destination by the receiver application or devices. Meaning, without protocols, devices wouldn't be able to understand the electronic signals they send to each other over network connection. One computer could be sending its data in 8-bit packets, while the receiving computer might expect the data in 16-bit packets, and so on. Okay, now, there are three main types of network protocols. The first one is communication protocols, include basic data communication tools like TCP/IP and UDP and also HTTP. The second one is security protocols, include HTTPS, SFTP, and SSL. And the third one is management protocols, such as ICMP and SMP. And also there are hundreds of different network protocols, and each one of them is designed and kind of developed for a specific purpose or environment. But UDP and TCP/IP are the most widely used in our industry. So let's start with OSC and UDP, and then at the end we can talk about TCP. Okay, let's back to our network editor to show you how you can use them with some simple example. And since I just want to send OSC messages on a local network, I just open another instance of TouchDesigner to receive them. So let me bring this one here and then get rid of this one. Okay. And okay, so just to mention that I only made this setup as an example. For sure, you can receive OSC or UDP messages from any application or devices that support OSC or UDP. I know it's a bit confusing, but just hold these thoughts that these two are separated TouchDesigner session and they are not connected, at least for now. Okay, I think it's kind of good, so let me also bring this one here. Yeah, good. And yeah, back to OSC. OSC stands for Open Sound Control. It's a standard protocol for communication or exchange messages between computers, application, sound synthesizer, and other multimedia devices that are optimized for modern networking protocols. there are dozens of applications of OC, such as real-time sound and media processing environment, web interactivity tools, software synthesizer, and also there are many programming language and hardware devices that supports OSC. And such as many other applications, TouchDesigner also supports OSC. We have OSC in and out chop for sending and receiving chop channels, and also we have OSC in and out dat to send and receive dat tables. So yeah, I think this is it. Then yeah, let's start with a simple example. First, I need to create some signals so I can send them out. So I'm going to bring a noise chop here. I'm gonna add more channel, 2, 3, and now I can bring the OC out and select them together. Okay, let me give you an overview of OCChop. OCChop sends all of these input channels to a specific network address with a specific port. With these protocol parameters, you can select if you want to send them to one specific computer or application, or you can just multicast them if you want to send the same data to a multiple computer. And also, you can specify an IP address here, but since I'm going to send them on a local network, I will just leave it as a default. And you can change the network port number here to send them out to, for instance, 9595 port. And also you can, with the max queue size, you can specify the maximum number of messages that you want to send at the single time. And also you can change the unit, as always, from sample to frame or seconds. And with the numeric format, you can choose the data format if you want to send the data between 32-bit integer, 32-bit float, or 64-bit double. With the data format, you can specify how this chop formats the outgoing message, sample, time slice, or transpose. So, for instance, if you put it on the time slice, sorry, and now you can limit the size of outgoing package and split them equally by changing the max message byte, this one. And the rest is, yeah, it's okay. So one thing to mention that, yeah, the OCChops only uses UDP protocol inside of TouchDesigner. And if you want to use TCP protocol, you need to use TouchOutChop. That one I will explain in a minute. Okay, cool. Now that we set our sender in this side, let's make a receiving node. So I'm going to bring the OSC in and put it here. And again, since I'm sending the package on a local network, the only thing I need to change is network port. It needs to be on the same port as the sender. So I can just copy and paste this one here. And this is it. Now you just made a really nice connection between these two instances. Okay. So this sort of communication between application is essential when you are working on a performative patch or any sort of system control, or even when you want to make a UI for your system, but you don't want to put everything inside of the same TouchDesigner processor. Now we have this small nice communication network. Let's use it for a small example. I'm going to bring slider, maybe 2 of them. I'm gonna add a null for each of them, and then I can merge them together. And now I can replace this one with this one. Great. And from this side, I can bring noise top here, and also I can reset channel, and I can use a select. I'm gonna select V1 and then V2. No. Good. And maybe I'm gonna rearrange. So I'm gonna use the first one for period. So 0 to 1. So you can use a mass. Rearrange number from 0 to 1. And for this one, I'm going to use maybe harmonic 2 to 6. This one for period, and this one for harmonic. Okay, great. And now from this side, now I can control this texture with these two sliders. This one for period and this one for harmonic. And as you can see, there is a slightly kind of latency, but it's not that much. I can definitely use it, no problem at all. Great. And again, as a reminder, you can send these signals to any other computer or devices, since we're sending the OC message over UDP protocol. And it is same for OCDAT, both sending OC package over UDP. UDP protocol instead of TCP. And it brings this question, what are the UDP and TCP, and also what's the difference between these two protocols. I'm going to start with the UDP. UDP stands for User Datagram Protocol. And like other network protocols, it is a standard method for transferring data between two computers over a network. But compared to other protocols, UDP sends packets directly to a target computer without establishing a connection first, or checking whether they arrive as expected or not, meaning that UDP avoids the overhead of error checking and correction in the protocol stack. On the other hand, we have TCP. TCP stands for Transmission Control Protocol. It is also a standard method for transferring data between two computers or application or programs over a network. Same as UDP, it is designed to send packets across the internet, but the difference is TCP is designed to guarantee the successful delivery of data over network. Meaning that in a TCP, two computers start communication first by building a connection by a process called handshake. And only once this handshake has been complete, one computer transfers data packets to the other one. In comparison with the UDP, UDP doesn't go through this process. Instead, one computer can simply begin sending data to the other one. And that is why UDP is faster than TCP. Also, TCP sends data packets in order. So each packet should be received, and when it's confirmed, it sends the next one. And if for any reason one package doesn't arrive, TCP sends it again, or sometimes it just stops sending until the next handshake. These differences create some advantage because UDP doesn't require a handshake or check whether the data arrives or not. It can transfer data much faster than TCP. But this speed creates trade-off. If a UDP datagram is lost in transit, UDP doesn't send it again. So as a result, applications that use UDP must be able to handle these errors. Okay, now to test TCP, we have a couple of different choices. I'm gonna start with TouchOutChop. Let me bring it here. TouchOutChop is highly optimized for TouchDesigner to TouchDesigner communication, and you can use it to create a high-speed connection between two TouchDesigner sessions, something like what we have at the moment. You can send the data over TCP, you can send it over UDP, or you can simply multicast to send the same data to multiple computers. Same as OCChop, you need to specify the network port. So I'm gonna specify it like 8585. And also you can define the maximum number of messages that you want to send at the single time by max queue size. It's super simple. Now we have our sender. Let's feed it with some signal so I can receive it at the other end. So I will bring the LFO. Maybe two of them. And merge it again. And go. Now I can go to the other end. Touch in. And I just need to specify the network port, copy and paste it here. Okay, now you have it. So let's use a select and channel 1 and channel 2. Okay, now we have it. Let's use it for continue this example. This time I'll bring level top, add it to this one, and maybe I can use it for yeah. So I'm going to rearrange these two values. -1 to 1, and also this one, -1 to 1. Oh boy. Great. I can use this one for my red channel, and maybe I'm gonna use the other one for contra. Yeah, something like this. And also we can compare. Yeah, I don't think, yeah, at least I cannot see any latency, but yeah, I think it's okay. Great. Okay, these two are both great chops when you want to send or receive channels through UDP or TCP. But what if you want to send or receive tables? Then we need to go to the dat work. Let me first make a simple dat table. I need to go to dat and then table. Great. Table dat is more like a blank list. You can create your list by adding rows and columns of cells, and each of these cells can hold a text string. And to be able to make or edit your list, you need to first toggle on these exact dimensions and then activate the viewer. Now, let's make a simple RGB color values. I need 4 rows, and then I need 2 columns. So red green, blue, and alpha. And also the red is something 1.2, 0.5, 0.5, and alpha 1. Okay, now that we have our table, it's a really small table, then we can send it through UDP or TCP. We have a couple of different options to do that, but I'm going to start with TouchOutChop. TouchOut that. These two here, and then deactivate this one. TouchOut that is also optimized for TouchDesigner to TouchDesigner communication, and the nice thing is always keeps the order of all of this information, and you can pretty much be sure that you received all of this information without any change whatsoever. Okay, same as the TouchOutChop. First you need to select your preferred protocol. I'm going to choose UDP, and I'm using the UDP because I don't care that much about handshakes, and also I don't want to have any bug issues on my network. For instance, if something goes wrong with my network connection, or if I just close one of these instances by accident, or if I'm sending the data through the internet and if one of the computers turns off, or things like that. When I'm using UDP, I can be sure that UDP is still sending and receiving information without concerning about the successful handshakes and things like that. Okay, now you need to specify the port number. And this time go to 9898. And then you can go to the other end and make your receiver. Touch in. And you need to select on the protocol because I'm using UDP, and then it should be same port as the sender. Now I can change my table list, and by each change, touch in recreates the list again. So let's test it. This time 1, yeah, 0.5. Yeah, great. Now, sometimes instead of channels or tables, you need to send out the texture, like 2D texture. There are plenty of different ways to sending and receiving your texture through a local network or internet. So let's first start with the local network. And let's bring the spout. I'm gonna spout out, and I'm gonna feed it with something like movie file in. Spout is an excellent open source texture sharing protocol when you want to share real-time texture or video or image between Windows applications. It has a low latency and natively supports by TouchDesigner and I believe many other applications. And the good thing is it supports pixel format up to 32-bit float RGBA. And in order to use Spout, we need to assign a sender name. At the moment is td-spout out. We can say test1. And from the other end, we need to bring spout in, and then simply assign the same sender name here. Okay, great. In this example, I'm using TouchDesigner to receive my texture, but of course you can receive it in any other application such as processing, Unity, MaximSP, I don't know, MadMapper, Resolume, and I believe many other applications. Basically any other application that supports Spout. But remember, that Spout does not transfer texture over a network to another computer. So if you want to send or receive your texture over IP or on a Ethernet-based LAN, then you need to use NDI. So let's bring the NDI out. This time I can bring noise. Solution to great, and from the other side I need NDI in. Source name is 2, and then this. NDI stands for Network Device Interface, and it is a high quality network based video and audio sharing protocol. With NDI, you can share textures between applications. You can connect video equipment over a network. You can see and access content from your capture system or media server or any NDI enabled device on your network. For example, you can use NDI to send your presentation slides from one computer and then receive them on another computer used for live streaming. And all of this communication can happen at the same time, real time. Or you can set up a display in your studio to show an NDI source coming from a video production software like OBS, and more and more. If you never use NDI, I strongly suggest just to look it up and learn how to use it and how it works. I think it's great. And now let's see how we can use it inside of TouchDesigner. And before I forget it, I need to say NDI-Top is only available with the educational, commercial, and pro keys, at least as far as I remember. Okay, now, same as Spout, you need to assign a source name. It can be anything, so it can be anything. So let's just change it to test3, and then the source name, you can change it to test3. And also you can assign a failover source name. It's super handy because if the first source or main source fails to receive by receivers, they will instead try to connect to the specific failover source. The failover name should be a machine name. With this FPS, you can specify the stream frame rate, but be aware that the higher the FPS, the more compressed the file. For example, 1 FPS, 1 has the less compressed, and 60 FPS has the highest compressed algorithm. You can also send the alpha channel if you toggle this include alpha on. And what else? And yeah, the most important things, unlike the Spout, with NDI you can stream audio sources synced with the video sources. So the only thing you need to do is just assign your audio chops here. Great. So let's move on to our last example. And finally, the TouchOutTop. TouchOutTop sends texture or video source over TCP. The receiver or touching top can be inside of another TouchDesigner instance on the same machine like what we have in here, where it can stream the source by TCP to any other computer connected to the network. And unlike the NDI, this one supports HubQ alpha and uncompressed video. And it is kind of important because streaming uncompressed source is so helpful, especially when you need to keep the quality of the source, or when you want to send channels data by top texture. Let me give you an example. Sometimes we're dealing with a massive number of channels. For instance, when we want to record or send out DMX channels with many universes. In this kind of situation, using chop method is not the best choice, since recording or transferring these amount of data with chops makes the output file a bit too large to transfer. And then of course, as a result, you need to deal with too much latency. So I think the best way is to first convert all the channels to texture, and then we can easily transfer the texture with TouchOutChop. TouchOutTop. Okay, let me give you an example. Just imagine that we want to stream 200 channels. Let me bring noise chop, and let me just make 200 channels real quickly. 200 channels. Okay, now we have 200 channels. For sure, we can still use chop methods like TouchOutChop or OCChop, but in this sort of situation, I prefer to convert my signals to texture. So let's bring chop to, and now we can drag and drop this one here. Great. So now if you look at this texture, you can see we convert all of these channels to pixels, and each of these pixels represents the value number of each channel with the same order and length. Also, if you look at the texture size, it is so small. That's great. And now we have our channels on top. The most important thing is not to compress this texture whatsoever. Otherwise, part or all of the information will be disrupted, and guarantee our data transferring method will be failed. So the solution is to keep it uncompressed while we transfer it. And this is exactly why the TouchOutTop is so useful. Let me connect this one. And also you need to bring the receiver to this and touch in. And now we can just simply change our video codec from HubQ to uncompressed. And of course, we can simply just change the network port to something like 7575, and from this side 7575. Great. Now the good thing is we can simply change the FPS without losing any quality, but this time you need to be careful with latency. More FPS meaning a larger file, and as a result more latency. And finally, I think the only thing I need to say is to just remember to always toggle on cook always. And of course you can use HubQ or HubQ with alpha if you don't want to use uncompressed. And I think this is it. Okay, let's back to the touch in to this side. And since I made this connection over a local network, I don't need to change anything in here. But if I wanted to receive it on a different PC, I could just add the IP address of the sender in here. And now let's convert this texture to a channel again. We can use this time like this, top 2. And because we just use the red channel, we don't need green or blue or alpha. and then I need to go to the crop page and then crop method and set it as full image. Okay, now if I check this one, I can see I have 200 channels. Also in here I have 200 channels, same channels, same information, I believe without that much latency. Great. I believe the only one is left is the shared memory here, shared memory. But the thing is, for using this one you need to have a pro key, and I believe if you're using a pro version you already know how to use it, so I'm gonna skip this one. Okay folks, I think that was the first part of this session. I know I made a lot of quick and dirty examples, but I think you got the point. So let's move to the next part. Okay, now that we have a better overview of network protocols and almost all the possibilities to send and receive signals with TouchDesigner, let's make a communication network over the internet to control our patch. In this part, I want to use my smartphone to make a wireless controller with a simple UI interface. So, in order to use my phone, I need to download an OC app. OC apps are control application for any software or hardware that supports OSC. Most of these applications are available for Android, Windows PC, and Mac, so it doesn't matter if you're using an Android or iOS phone or tablet. For this example, I'm going to use TouchOutCoop, this one. But of course, you can use 𝗕𝗟𝗨𝗘𝗣𝗥𝗜𝗡𝗧 or any other open source app like OpenStage Control or Oscillation. So to connect the TouchOutCoop, first I need to open the app on my phone. Now I need to set up the connection, so I need to go to the OC page. Okay, then I need to enter the IP host. In this case, the IP host is my laptop local IPv4 address. So if you're using a Windows machine, you need to open command prompt and type ipconfig. Yeah, this is your IPv address. So let me check. 192.168.166. Great. So it's already fixed. Okay, then I need to set up for my port outgoing. I think, yeah, 7000 is okay. I don't need to change it. And I need to back to my setting page and also set the same IP for the TouchOC bridge. Yeah, it's already set. And now it's great. So it's done. Yeah, this is one of the default layout. So let's test it with OSC in. Now I need to change the network port to 7000 and press one of these keys. Okay, great. TouchOC comes with a nice desktop editor that you can download for free, I think. And it's really easy to use, so I'm going to make it a really simple UI very fast. So let's open TouchOC Editor. And yeah, it's super simple. So basically you can just easily change the size of the layout here. You can change the orientation. At the moment it's vertical, so I'm going to change it to horizontal. You can add as many pages as you want, but for this example I'm just going to use single page. But the idea of having a couple of pages, more like you can just have one page for buttons, the other page for faders and things like this. And also you can normalize the value. At the moment is, I believe it's more like a 0 to 1 value, so I'm not going to change it. And okay, now we can just easily start designing some stuff. So I'm gonna bring this XY pad, put it here, press the shift, something like this, and then I can bring toggle button. I can copy and paste it, maybe 3 is enough, like this. And also I can bring fader horizontal, and I can just, yeah, something like this. Great. Maybe making some space. Okay, now I can change their color. You should make a specific color chart for your color coding. I think it's a good tip to stick to one color chart all the time to avoid any mix-up while you're using your layout on a live performance or something. Okay, now can change this one to green, green, and again green. This one to purple, same, and same. And I'm gonna just leave this one red. Okay, great. Now I can just save it, and then I can just press on this sync button to download it. Okay, it says, yeah, it asks me to open TouchOC and go to the layout and press add. Okay, layout, add from editor, download. Great, done. Now I have it here. Great, I can just stop sync and then back to TouchDesigner. I need to reset values and then just play with these faders, press on these toggles and this one, and reset value, reset channel again. Great. Perfect. Now I have them all. I can use select chop. Connect this one. 1, 2, 3, 4, 5, 6, 7, 8. This one, fader 2, fader 3, toggle 1, toggle 2, toggle 3, and XY1 and XY2. Great, let me check it. XY, great. Fader number 1, fader number 2, fader number 3, toggle button. Great. I'm going to use the PBR patch that I made last time, but of course you can use this method for almost every sort of purpose. So I'm gonna just split my screen and my geo here. Okay, let's start with these X and Y pad. So I'm gonna bring mass chop because I want to rearrange this value. I'm going to do the same for this one, and then on the range page I'm gonna rearrange it from 0 to 1 to 0 to 360, and same for this one. And then I can just add the null at the end of this branch, and in here my geo. Okay, I'm gonna use the first one for the x-axis and the second one for the y-axis. Okay, let me check it. Yeah, okay, it's nice, but can make it better. So let's add a filter chop here. Same for this one. And now we can check it again. Okay, now it's much better. But also we need to kind of reduce this one to something like 0.5. Yeah, that's great. Good. And we have 3 toggle buttons, and also we have a bunch of lights in our scene. So maybe on the PBR, on the ring page, we have this light. So the first toggle here, great, so I can use a null, and then I'm going to use this one for turn off and on the ring light. Okay, let's check it. It's nice. And also we have these 3 faders, sliders. So let's use the first one for our camera. Let's find out something between maybe 2.5 to 6.5. Use a mask chop again. Rearrange it from 2.5, 6.5. Okay, let's do this one. Okay, it's good. Again, I'm going to use filter chop 0.3 this time, and yes, that's nice. And I'm going to just rearrange this one from 6.5 to 2. Yeah, okay, that's better. Great. And what else? So we have yeah, I have a noise in here, noise sub. So maybe I'm going to use the second one. Open the mask chop again, and I'm going to rearrange it from 0 to 0.13, and the filter chop again, maybe 0.1 is enough, and then the null at the end of let's use it for amplitude. So yeah, okay. I don't know, I don't think if we really need this filter, but and also we can just move it to 25. Now we can add this filter. Okay, nice. And what else? So let's bring this to here. And this time maybe let's back to our PBR material and maybe to RGB, and maybe this time they are great. This metallic parameter is nice. So I need to bring the null and then use this one for these metallic parameters. And again, I can just use a filter to smooth it out. 1.3. Yes. Okay, nice. And yeah, great. I think it's kind of enough for now, and also it kind of looks nice. Yeah. Okay, folks, I guess now you can start designing your UI and experimenting with all of these parameters inside of your patch. Test and compare all of these protocols together and find the best solution for each specific purpose. And kind of remember that using your phone has a lot of advantage. It's a cheap solution and usually does the job, but of course it's not the perfect solution. You still need to take care of some latency here and there and smooth out your input signal, stuff like this. But in general, I think it's a good practice. And I'm sure you'll find lots of different creative ways to use your phone as a controller. Great. So I wish you all a wonderful summer and hope you have a great weekend. Thank you for watching and goodbye.